So it may sound that when we started with the admissibility of forensic evidence, we have actually started from the end of the process, which is actually true. But the questions of admissibility and in general the questions of interpretation of forensic evidence are the key questions we need to consider before we start processing the evidence and perform any forensic analysis. So this part of the lecture is essentially an introduction to crime scene investigation, which will be the main topic for the next lecture. So let's start from the beginning then. What are the types of forensic evidence and how this physical trace is deposited? So the question is, what can be considered physical evidence? Well, the answer is pretty much anything you can think of can be considered physical evidence, right? All these things that you see on the screen, that anything you can think of might become an evidence in a criminal case. And the purpose of recognizing physical evidence is so that it can be collected and analyzed, right? And the various types of evidence are analyzed in the respective divisions of a crime lab, as you know. It's also important to recognize that the final weight of the evidence is essentially decided by a jury, not by a forensic scientist. So physical evidence essentially includes any objects that can establish that a crime has or has not been committed, or can provide a link between a crime and its victim, or a crime and its perpetrator. How the physical evidence is deposited? Well, as you know, the trace is left through a physical contact according to Lockhart's exchange principle. Although, to be precise, some traces can actually transfer between objects or people without a physical contact, but let's leave this aside for now. So this triangle actually illustrates this process. So we have the suspects, the victims, and the scene as our vertices of the triangle, and our evidence, our trace that later becomes an evidence in the center. And this evidence essentially links those three vertices of this triangle. It is very important to realize that the initial step of evidence collection is crucial. So if the investigator cannot recognize physical evidence or cannot properly preserve it for lab examination, no amount of sophisticated lab instrumentation or technical expertise can salvage the situation. So every contact leaves a trace, but the process can actually be affected by numerous factors. For example, the force being applied on an object or person, the nature of that contact, the properties of the surfaces that came into contact, and obviously the duration of the contact. So the longer the duration, the more of that trace we would expect to be transferred. On the top of that, there are also multiple factors that may affect the detection of the trace, right? And again, that might be the nature of that surface, when that contact has occurred, and how much time has passed since that contact, and obviously the nature and extent of the movement. So all these factors, all these topics are very important, and honestly, each one of them requires a dedicated lecture at the minimum, if not a dedicated course. So this is obviously beyond the scope of this introductory course, but if you're interested to explore and learn more about these and other topics in forensic science, I advise you to check the forensic science major or minor curriculum through the links I posted in Canvas. In this lecture, in this course, we'll just talk briefly about these topics and obviously many others. So what is the value of physical evidence? What can physical evidence do? Well, it can do a lot of things, such as help to establish that a crime has been committed. That's the first question, right? Then establish the different key elements of that crime, place the suspects or the victims at the crime scene, obviously establish the identity of suspects and victims, and many other things. Perhaps one of the most important, I would say, is to exonerate the innocent person. And we'll discuss this later in our Module 6. One other thing that many people don't really realize is that the physical evidence is much more reliable than the eyewitness testimony. Okay, and this is important to realize. And again, we will get back to this topic later on. When dealing with a crime scene investigation, we usually asking the following 6 questions, known as 6 W's. What happened? Where? When did that happen? Who did that? How that happened? And why? Answering some, or preferably all of these questions should help us to reconstruct the series of events that have happened at the crime scene. So by now it's pretty clear, I think, that the forensic evidence can assist in answering the first 5 questions and provide support for the first essential point that needs to be proved beyond a reasonable doubt during trial, that a criminal act was committed, actus reus. While the last question, why, is clearly not in the forensic science domain, as it's beyond our capabilities. It more relates to criminology rather than criminalistics. We'll discuss the first 5 questions in our CSI lecture and later through the course, but let's first focus on these 2. What and the ultimate question of who. Now, I'm slightly changing these questions as they relate specifically to forensic evidence. So, what is the nature of the trace, and if it is original source can be identified? In other words, which person or object has left this trace that later became an evidence, and can we identify that source or not? So in this example of a fatal shooting, let's see how the evidence is created and how it can be used to link a person to a scene or an event. So in this case, the perpetrator of the shooting enters a home and kills the victim with a gun, which he takes with him when he flees the scene. Per the exchange principle, contact between the perpetrator and the scene has created physical evidence. The scene will retain traces of the perpetrator, and the perpetrator will carry with him the traces from the scene. If the scene is processed, many types of evidence may be potentially recovered, such as fingerprints and bloodstain patterns. One of those patterns could potentially match the outline of the gun that is later found, and the fingerprints can be used to identify the suspect through the fingerprint database. Police might go to his house later and find the weapon, which can then be compared to the blood pattern found at the scene. Fingerprints on the gun could link it to the perpetrator, while the bloody pattern links the gun to the crime scene. So the perpetrator is linked to the gun, which is linked to the scene through evidence that arose from contact. And this linkage is made by transfer evidence. After the evidence items from crime scene arrive at the forensic lab, they will go through a series of examinations in different lab units. The examination of physical evidence by forensic scientists is usually undertaken for identification and comparison purposes. Identification has its purpose in determining of the physical or chemical identity of a substance with a near absolute certainty as existing analytical techniques permit. A comparison analysis requires both a suspect specimen and a standard or reference specimen being processed according to the same tests and examinations for the ultimate purpose of determining whether or not they have a common origin. It is important to remember that all evidence analysis starts with non-destructive techniques and proceed towards more destructive techniques until we get an answer to the relevant questions being asked. So, for example, if we have a finger mark in blood on a gun, we'll try to develop first that fingerprint, take a picture for further comparison with a reference fingerprint or a database, and only then proceed to the DNA analysis, and afterwards transfer this gun to the ballistics lab for further analysis. The main objective of the identification analysis is to categorize the substance in question. Usually these tests are divided into two categories: presumptive tests. For example, if we want to ask a question if this red stain is blood, and confirmatory tests, which would help us to answer the question if this is human blood or maybe kangaroo blood. Okay, and we'll talk more about these tests later. However, before we can proceed with the identification analysis, we must establish scientifically accurate and robust methods for testing the unknown sample. Once these methods have been established, we can apply those routinely to prove the identity of the evidence materials. Essentially, the identification process requires that the number and type of tests needed to identify a substance would be sufficient to exclude all other substances. This means that we need to develop a standard comprehensive analytical scheme that will eliminate all but one substance from consideration. These analytical tests would be specific to different types of evidence. So, for example, if we want to find out if the particular suspect powder is indeed a cocaine and not a laundry powder, then the test results on the powder must be identical to those that have been previously obtained from a known cocaine sample. And the bottom line is that the conclusion obtained by these tests must be scientifically valid and being beyond any reasonable doubt in court. Now, comparative analysis, as its name suggests, is based on comparison. The aim of comparative analysis is to determine if a specimen in question and a standard or reference specimen have a common origin. Now, when reading the textbook, you might get an impression that the identification and comparison analysis are two completely different processes, which is not entirely true. In reality, these two are often complement each other, but don't worry about that too much, as it will become clear later. Now, many forensic tests rely on a comparative analysis. In this analysis, an unknown specimen and a standard specimen are subject to exactly the same tests and examinations with an ultimate purpose of determining whether they have a common origin. So this process requires two things: an unknown source or question object, and a reference that we would compare to, which is a known object or person or a database. So, for example, if we have an unknown source object such as hair from scene, we will compare these to a known object, which is suspect's hair. Or if we have a paint chip from hit and run scene car, we'll compare it to the paint chip from suspect's car. Or shoe impression recovered at a scene to the suspect shoe. Now, in this process of comparison, we will usually look at a combination of several features selected at both objects, the evidence in question and the known reference sample. Now, if there's a discrepancy between these two, in other words, some of these characteristics do not match, then the conclusion is usually pretty easy. The objects on the comparison are not from the same sort. However, if all the properties on the comparison between the two objects match or there is no discrepancy, does this really mean that these specimens came from the same source? Not necessarily. And to answer this question, we need to look closely at the nature of characteristics on the comparison. Are they truly unique or not? In this process of evidence characterization, we can take one of the following pathways: classification and individualization. The process of classification searches for features that would help to organize similar objects into groups. So in this process, we will look for class characteristics, which are the properties that all the members of a certain class of objects have in common. All the items in that group will be identified by comparing their class characteristics with those of known standards according to previously established criteria. However, given that these class characteristics can be found in other objects within the same group, they are not unique. On the contrary, individual characteristics are those that can be attributed to a single common source rather than a group of sources within a very high degree of certainty. And forensic scientists will usually search for as many characteristics as possible to compare and then determine their individual and collective value. So like in this example of taxonomical classification of plants, we go from the very diverse group of plants that share many different characteristics between them to a less and less diverse group until we actually reach the final individualized group of a single species. The comparison process, however, does not always end up with an individualization outcome. In fact, in most cases, forensic analysis of the evidence may not provide a clear answer on the unique origin of that trace. So let's imagine we compare two paint chips of a similar color, one that was found at a scene of a hit and run crash, and the other obtained from a suspect's car. So they might have the same layers of paint, the same chemical characteristics of each layer, but usually we would be able to associate that chip with a car model only rather than a particular vehicle. And that's because these are class characteristics that have a relatively high probability of originating from another car of the same model. As a result, the evidential weight of individual characteristics is obviously higher than of class characteristics.